All right, folks, we're going to start 7.3, but first we're going to do a little bit of a warm-up here from last week's work. I got a new handy-dandy pen, so we're going to see how this works. It may work really well. It may work not so well. All right, so as you can see, it says tell whether the angles are adjacent or vertical. And so since we have my writing utensil here, since we have, two angles that are right next to each other, we would say that those are adjacent angles. And then over here, we have angles that are across from each other, so we'd say that those are vertical angles. Now, adjacent angles don't necessarily equal each other, but we know that a straight angle is 180 degrees, so we're going to say equals 180 degrees. Actually, it's working pretty well. And then everything in here is going to equal that, right? Because this angle right here and this angle right here equal 180 degrees. So we say x plus 96 plus 5x. Kind of run out of room. We'll combine like terms, so we get 6x plus 96 equals 180. And then we'll have a two-step equation here where we're going to subtract 96 from both sides. We get 6x equals, so it would be 184. All right, and so now we're going to say 84 divided by 6. And x equals 14. All right, coming on over here. Now, vertical angles are equal to each other, so we're going to set these equal to each other. Plus 42 equals 2x plus 1. Oops, plus 1. So we just have to bring this over here and maybe 42 over there, or we can go vice versa. Now if I subtract 2x, what's going to happen is going to give me two negatives, which I'm fine with, right? But if you would like to go the opposite direction and get positives, right, we'll bring the x over here and then bring the 1 over here. That will give us positive, so we're going to subtract 1 from this side, which would give us subtract 1 from the other side, and that would give us 41 on this side. And if we say x minus an x over here, right, minus an x over here, 2x minus 1x equals x. So we have x equals 41. All right, so tell whether the angles are complementary or supplementary, then find the value of x, right? So complementary means that they add up to 90. Oops, it doesn't look as good as I wanted it to. 90, right? So complementary forms the 90 right there. And supplementary, remember, the s forms the 8 of the 180. But anyways, so this is complementary, so we'll say complementary, and this one over here is supplementary. Now, these are going to add up to 90 degrees, right? So we have 10x plus 30 equals 90 degrees. Two-step equation, minus 30 off that side, minus 30 off this side. We get 10x equals, x equals 60. Divide by 10. Divide by 10. X equals 6. Right, over here, we know that from here to here is 180. Those are supplementary, so those are going to equal 180. Actually, I'm going to put that somewhere else. And we have 4x plus 40 plus 3x. And combine like terms, we get 7x plus 40 equals 180. Subtract off 40 from this side, subtract off 40 from this side. I'm going to come right up here. I get 7x equals 140. Oops. 7x equals 140 divided by 7, 14 divided by 7 is 2 with the 0 on the end, so x equals 20. Sorry for the little bit of a mess there. Alright, so today we're looking at how can we construct triangles, not as much as classifying them actually, excuse me for that, that's a typo. We're looking just at classifying and then determining different angles, knowing what all three angles add up to be. And so we have right here, we have an acute triangle. All angles are acute, so this angle, and this angle are all less than 90 degrees acute, right? Less than 90. All right, less than 90. One obtuse angle, that would be right here. One obtuse angle means that one is greater than 90 and the rest are less than 90. You can see like right, this angle right here and this angle right here would be less than 90. Right here, one right angle, that is called a right triangle, and then an equiangular triangle means that all three of the angles are equal, right? And so I guess over here I should make sense that these don't have to be equal. These could be all different angles less than 90 degrees. All right, so these ones are all equal, and that's what that little red bar means. Right here, scalene, that these have no congruent sides, right? These little tick marks means that the sides are equal to each other. So there are none on this one, that this side is different than this side, is different from this side. Isosceles, I also like to say this, I saw two of these. Isosceles, I saw two of these, right? Because they have two angles, sorry, excuse me, two sides that are congruent, equal to each other. Okay? Looks like a little mad person, right? With a little face there. All right, and then an equilateral triangle, obviously, all three sides are equal, right? So this side is equal to this side, is equal to this side. Okay. All right, so we're going to classify this triangle right here, and one key determining factor right here is that it has a right angle, so we'll say that it's a right triangle, but also we see that this has something right there and something right there. We can also say that this is, I saw two of these, isosceles. Hopefully I spelled that correct. Let's go back and check. Isosceles. I-S-O-S-C-E-L-S. I did. Way to go. All right, and then looking right here, we're going to go back to our page. We see that if you have all sides that are equal, it's an equilateral triangle, but it's also called an acute triangle because all angles will have to be under 90 degrees in order for all sides to be equal to each other. Oh, I realized I made a mistake, so I'm going to go back. I'm going to classify this triangle first, and so I'm looking right here. I have one angle that is larger than 90 and the rest are smaller, so I'm going to say this is an obtuse. And it's also, that's I think all we can say about it right now, because it doesn't have any tick marks for the side. Over here, I see that two angles are equal and two right there, and so I know that if I go back, to this screen right here, one obtuse angle, right triangle, acute, equiangular, equilateral. Right. So all I can really say right now is that based off of the sides, and I say isosceles. Nope. Isosceles triangle. All right, so we're back over here, and we're looking right here. We're saying these are right triangles. I can say that this is an equilateral because all three sides are equal, but I can also say that it's an equiangular as well. Right? So equal lateral. Also, I actually can't remember how to spell that, so I'm going to go back. EQUIA. EQUIA. Right, so equilateral, equiangular. All right, classify the triangles here. So pretty simple. We're looking at the different ones that we can see. And we see that two sides, although it has been kind of knocked over on its side, this triangle just looks like this. Well, a little bit better, but 40, 70, 70, right? If we stood it up, right? So that would just be upwards. Get rid of that. All right, so we see that this is a isosceles triangle. It has two sides of the same. I can say this is isosceles, but I can also say something else. I could say that it is a right triangle. Sorry for my mess ups right there. I'm dealing with this pen. 90-degree triangle, and so I would say that this is a right, but also know it's an isosceles, so I can be a little bit more specific. Right. Based off angle and based off of sides, right? So it's a right or an isosceles triangle. And over here, I can't say anything about sides because I don't know. I know that they're all different sides. I actually can call this a scalene. The scalenes don't have any equal sides. Go back to that little picture right there just to kind of show you. So no congruent sides. Right there, a scalene, and has one obtuse. Right, so I can do it by sides as well as angles. It's also known as an obtuse. All right, here again, it's an obtuse, isosceles. Right. Obtuse angle, one of them, and then we have two sides that are equal. Right here, 90 degrees, so it's a right. And also, I guess you can call it a scalene. I don't think I wrote that. And then right here, all angles are equal. We're going to call this an equal lateral triangle. Now we can do it by angles too. Equiangular, not something is used very often in classification. All right, our next object is to figure out measures of the different angles. Now, you can see here we have X, Y, and Z. They are all labeled different. There are always going to be three angles in a triangle, and they are always going to add up to be 180 degrees. Okay, now if we think about that, I want you to think about something. Think about a square really fast. Now a square, right, it's just two triangles put together, right? So triangle 1 and triangle 2. Now with a square, sorry for my bad drawing. Come over here and see if I can get a little bit straighter lines. All right, well a square has 4 right angles. Right? And so if you add up the angles inside of a square, right, it's 90 90, 90, 90. So 90 times 4. 9 times 4 is 36 with a 0. And so basically you know that 360. But if you break this in half, right, we know that this is 45. That is 45. And that's 90. Right? So 90 plus 45 plus 45 equals 180 degrees. That's why we know all triangles add up to be 180 degrees. Alright, so we're going to look at this right here and find the value of x and classify each triangle, right? So we know we have this angle, we have this angle, we have x, so we're trying to find. So I'm going to say x plus 28 plus 50 equals 180 degrees. Combine my like terms, x plus 78 equals 180. I'm going to subtract off 78 off this side. Subtract off 70 out of this side, x equals 102. And that makes sense because this is a obtuse angle. You can see that these are both acute angles, and so this one would have to be obtuse based off of how it's drawn, right? And so I'm looking down here. I'm going to say that it is. Oops. Obtuse. Alright, looking up here, I see that this is a right triangle, right, just based off of that. And so that equals 90 plus 45 plus x equals 180. Yes, this triangle too will equal 180 degrees, combine like terms. And I see that 90 plus 45 is going to be 135 plus minus off 135, minus off 135. We have x equals 45 degrees. And that makes sense because this is a right triangle, and this is 45, so the other one would have to be 45. Couple do on your own. If you want to pause, you can. Actually, no, we're going to do these together, and then you may do the other ones on your own, but pause if you need a second. So we're really just looking at this green triangle right here, right? And so if I redraw that out here, just to make a little more sense for me, I have x, x, and I have 128. Well, I know that all triangles are going to add up to be 180 degrees, and so I'd say x plus 128 equals 180. Subtract off 128. Combine like terms, 2x, sorry I did 2 steps in one, so 2x equals, what is that, 52. And to get this right, divide by 2, x equals 25, 26. Now I could check that by simply going back and saying, does this side equal, this side is 26 plus 26 plus 128 equal 180, so 26 plus 26 plus 128, and that does equal 180, so I know I gave myself a little check. Okay, again, just looking at the Cuba flag of Cuba. So we have 2x, where did I get that? I added this x and this x together. X plus 60 equal 1. Right? So plus 60 equals 180. Taking some shortcuts. Divide by 2, x equals 60. Right, so that makes sense. So 60 plus 60 plus 60 is 180. I did my check. Again, push pause if you need some time. Last page for you. All right. Actually, yeah, push pause, and then you may do these afterwards. I'll All right, so find the value of x, then classify the triangle. So again, just a couple more for practice. 75 plus 30 plus x equals 180. Combine like terms. 105 plus x equals 180. Subtract off 105 from this side. Subtract off 105 from this side. X equals 75 degrees. All right. Oh, getting some decimals here. All right. So we have x plus 105 and 6/10 plus 28 and 4/10 equals 180. All right. So x equals 105.6 plus equals x plus 134 equals 180 minus 134 minus 134, and we get x is equal to be 46. Make 40. Yep, x equals 46 degrees. I guess it wouldn't be degrees because the degrees is already labeled right there, but that's okay. Now sketch a right isosceles triangle, right? So it's not going to be as easy for me on here as it might be for you on your paper, but use a ruler if you are going to draw this because you need a straight edge. So we have a right isosceles triangle, so I'm trying to make this side equal to this side, even if it's not. If I put this little box in here, it means it's 90, and if I put that little sign there, those two little lines, it means that both sides are equal to each other. So that is A. And then B, I'll do over here, an obtuse scalene. Obtuse scalene. All right, so obtuse, I have to have an obtuse angle. And I need all my sides to be different lengths, right? So let's say 1 there, 2 there, 3 there. That tells me that each side is a different size. Scalene and obtuse, there's only one angle that is obtuse here. All right, folks, have a great one. Stay healthy. Do something nice for your parents. Talk to you later.